Now that we've looked at titration curves in great detail, let's see how we could use an acid-base indicator to find the equivalence point for a titration. So an indicator changes color in a specific pH range. For example, methyl red is an indicator that goes from red to yellow over a pH range of about 4.4 to 6.2. So we could say that's a pH range of approximately 4 to 6. Bromthiamyl blue is an indicator that goes from yellow to blue over a pH range of about 6 to 7.6. So we could say that's approximately 6 to 8. And phenolphthalein is an indicator that goes from colorless to pink or magenta over a pH range of about 8.2 to 10. So we could say that's approximately 8 to 10 here. Let's look at our titration curves and let's see which acid-base indicators we could use. All right, we'll start at the top left here. This was the titration curve for the titration of a strong acid with a strong base. And at the equivalence point, the pH is equal to 7. So right here would be a pH equal to 7. And so this was our equivalence point, right? So we drop down here. For the example that we did the math. It took 20 milliliters of our strong base to reach the equivalence point. So if you're doing a titration of a strong acid with a strong base, the pH is equal to 7 at the equivalence point. All right, so let's think about which acid-base indicator we could use for this titration. You want to choose an indicator that changes color in a range close to your equivalence point. For example, bromthiamyl blue changes color from 6 to 8, right? So at a pH of 6, bromthiamyl blue is yellow. So right here, bromthiamyl blue would be yellow. And then it would change to blue. You might even see some green in there, right? So you see a color change in this range. So bromthiamyl blue would be a good acid-base indicator to use for your titration. So when the blue color persists, right, you've reached the end point of your titration, and you've matched the end point of your titration with your equivalence point pretty well. So this is a good way to approximate the equivalence point. For a strong acid, strong base, we have a really steep titration curve, right? From a pH of about 4, let me change colors there, from a pH of about 4 to a pH of about 10. So we could have used the other two acid-base indicators too. Right, we could have used methyl red because methyl red changes from red to yellow in a range of about 4 to 6. And so that gives you a good approximation of the equivalence point. Or you could have used phenolphthalein because phenolphthalein changes to magenta, right, somewhere between 8 to 10. So because you have this really steep titration curve like this, right, you could have used any of the three acid-base indicators to find the equivalence point for your titration. All right, next, let's look at the titration curve for the titration of a weak acid with a strong base, and that was this example over here. So we started with a weak acid, right? In our example, we used acetic acid, and to the acetic acid, we added a strong base, sodium hydroxide. The pH at the equivalence point is greater than 7, right? So the pH was greater than 7. For our example, it was close to 9, right? So it was right about there, just under 9 was the pH for our equivalence point, and it took about 200 milliliters of our strong base to reach our equivalence point. All right, the reason why the pH is greater than 7 at the equivalence point for this kind of titration is when you've neutralized all of your weak acid, right, you're left with the conjugate base to the weak acid. And the conjugate base reacts with water to increase the concentration of hydroxide ions in solution. And that's why your pH is greater than 7. So go back and watch the video for this titration if you want to see the exact calculation. So for the titration of a weak acid with a strong base, the pH is greater than 7. You want to choose an acid-base indicator that changes color in a range greater than 7. And so for our example, phenolphthalein would work really well because it changes in a range of 8 to 10. Right, so right in this range, right in here, we would see a color change from colorless to pink or magenta, right? And we would stop our titration at that point, and that's a good approximation of the equivalence point. You wouldn't want to use something like methyl red here because methyl red changes in a range of 4 to 6. And you can see 4 to 6 would be right in here on our titration curve. So methyl red would be red, and then it would change to yellow somewhere in here, right? So you get a color change somewhere in here, and so you would miss the equivalence point. This would not be a good acid-base indicator to use. So you couldn't use methyl red here. All right, finally, let's move on to the titration curve for the titration of a weak base with a strong acid. So we're starting with a weak base, and so that's why our pH is in the basic range before we'd added any of our acid here. And in this case, the pH at the equivalence point is less than 7. The pH at the equivalence point is less than 7, and that's because, right, if you've reacted all of your weak base with your strong acid, right, you're protonating your weak base. So in our example, we used NH3, we used ammonia, right? And if you're protonating your weak base, then you're going to be left with NH4+, right, which is acidic. And so at the equivalence point, right, you have ammonium, which can donate a proton to water, and so you increase the concentration of hydronium ions in solution. And so at the equivalence point, the pH is less than 7. Once again, watch these videos if you want to see the exact calculation for that. So your pH is going to be less than 7. In our example, we got a little bit over 5. So right about there would be the equivalence point. So if you're thinking about which acid-base indicator do you want to use one that changes color at a pH less than 7. So methyl red would be a really good one to use here. Right? So methyl red would be yellow at a pH of about 6, and then it would change color to red here. Right, and that would be the end point of your titration where you see the color change for your indicator. And so that would be a good way to find the equivalence point. You wouldn't want to use something like phenolphthalein because phenolphthalein would change color up here, right? So at 10 it'd be pink or magenta, right? And then it would change color right about there, and then you'd get colorless. And so if it changed color here, right, you've missed the equivalence point. So phenolphthalein would not work for this titration. Methyl red would be the best choice.